Morning guys, today I came here with another proton NMR spectrum video. Here the first step is the same. You will first see the rule. First of all, you will calculate the number of the peaks, and then you will determine the chemical shift values, and after that you will find the integration value, and then you will deduce the structure. The same process as we have discussed before. And here you are given the IR spectrum and the mass spectrum that we are not using today, but we will talk about it later. Here are the proton NMR that we want to solve. As you can see, there is only one peak that is coming almost at about 3.7 ppm value. So, and only the one peak is given. The chemical shift value was also written about this spectrum, as it is not showing here. It is 4. It was 4. So it means the 4 protons are present here, and only the one peak is shown. Okay, the single peak may be due to the methane. If the 4 protons are present, we may write it as this. But as you may see that the chemical shift value is coming almost about 3.7 ppm value. This is a very large ppm value as for just for methane or methyl. As you may see, the for the alkyl groups the ppm value is just coming till here. If the values are coming here, it means it is attached with some atom with electron withdrawing atom, that is withdrawing its electrons towards itself. So it means it is not a methane. So it means there are this kind of structure may be present which are of the same chemical environment, like these two protons and these two protons. For them to have the same chemical environment, same type of the atoms should be attached here and here, electronegative atom. For example, if we talk about the oxygen atom, if the oxygen atoms are attached here, then those oxygen atoms should attach with something else also, but that is not the case here. So which atom is present here? So we will go to the chemical shift values here, as the chemical shift value is coming almost 3.7 ppm value. We will search from here. So this is not the range, and here this no, as you may see, no, these all are not. And here you may see this is coming in this range, but this is for the protons that are directly attached with the sulfur and the nitrogen atoms. Okay, and here you may see the chemical shift values are not coming because only there is only one kind of the protons, not the different kinds of the protons are present. So if we come here in this range now, if you see here, yes, this may be the case because at the end one atom is here attached and it needs no other type of the protons. So here this may be the case and this may be the case. So if we talk about these three things, iodine may be present, bromine may be present, chlorine may be present, the chemical shift value was the 3.7 ppm. So here we will see the 3.7 ppm value, in which range it is coming. Though in these three range it is coming, so it means that some type of the halogen group is attached with our this structure. So now it may be bromine, it may be chlorine, or it may be iodine. So I will write it here. Chlorine may be present here, bromine may be present here, and iodine may be present here. So if these three atoms are present here, but I have no idea which atom is present here, so what I will do? Actually, when we want to elucidate the structure from the proton NMR, we don't have anything about that compound or molecule except that we have that compound in its original form with us. So what we will do? We have a laboratory. What we will do? We will do the Lazine solution test. We will do some other kind of the detection test to determine either the iodine is present, either bromine is present, either chlorine is present. So now in this case, if our structure gives you the test, if it gives you the positive test for iodine, you will put here iodine, and if it gives you the positive test for the chlorine, what you will do? You will put here chlorine. Yes, you will put here chlorine. And what about if it gives you the test, positive test for the bromine? What you will do? You will write there, then it here just bromine. Now in this case we have this proton NMR spectrum of this structure, that is 1,2 dibromoethane. So now I told you that we will discuss here in the IR spectrum. We are not taking any information as no peak is given here, but in this mass spectrum you are determining very much information from this mass spectrum. As you can see here, first of all, your main focus should be these two lines. These two lines are of equal abundance, and these two lines should give you the peak at the 107 or 109 mass to charge value, and the mass peak is 186, 188 or 190. So if what first our response was that this is due to the bromine peak, because the bromines gives you the two peaks that are of relatively equal abundance. And here if you want to prove it, then you may take the one mass peak and minus here 79, you will take the answer of 107. So it means that this when the bromine is detached from your original molecule, then you take then you get a fragment that gives you the peak value at this bromine is present here. And the second thing here, it may be possible that your examiner give you at one side chemical formula of your structure, and it is most probably that it is given you in exam and you have to elucidate the structure from it. But if it is not in the examination, but you are determining the actual structures of some compounds that you don't know the spectrum, then you may use the lab. In the lab you should do some experimental work, and then you will know that which functional group is present, and from that functional group value you may easily elucidate the structure from the proton NMR spectrum. Okay students, so now these are some chemical shift value. These are also very helpful for you. You may take this screenshot or you may learn it. If you like my videos, then please like, comment and share.